This is a brief demonstration of GSE Systems' desktop design EP with a focus on offsite dose distribution. We are utilizing the Modular Accident Analysis Program, or MAP, developed by the Electric Power Research Institute, also known as EPRI. MAP performs severe accident analysis for nuclear power plants, including assessment of core damage and radiological transport. We will show that the desktop design EP has the capability to simulate real-time offsite dose distribution responding to interactive weather conditions. The demonstration plant for this scenario is a four-loop PWR plant. The plant has two units with a spent fuel pool and a shared auxiliary building between them. The EPRI MAP program running on the design EP platform is used to model all components in both operating units and the auxiliary building. The MAP program also includes the offsite dose model that this video focuses on. The demonstration scenario is a station blackout on both reactor units, which causes both reactor cores to melt and breach their vessels. A small containment leak allows a release to the environment about 6 hours after the blackout occurs. Additionally, the spent fuel pool gradually heats up and begins to melt. This also results in a leak, but not until about 21 hours after the start of the blackout. This graphic shows a geographical map of the Hong Kong area. The PWR plant site is located at Daya Bay near the upper right corner of the map. The largest partial circle on the map is an 80-kilometer radius from the plant location. The map indicates 10 locations in the area where the dose value will be displayed in millisieverts. The dose is also illustrated by circles that increase in size and change between four colors as the accumulated dose increases. Green indicates safe, yellow signifies an increased risk of cancer, orange warns of acute radiation illness, and red indicates a 50% rate of mortality within a month. The dose itself can be displayed as internal dose, meaning dose through inhalation, external dose, meaning dose through cloud shine, ground shine, or deposit onto skin, or the total dose, which is a summation of internal and external doses. The three buttons near the upper left side of the graphic are used to select the indication mode. Location number 1 is always located 1 kilometer downwind of the Daya Bay plant site. The other 9 locations are away from the plant site and are independent of the wind direction. The closest location, labeled 2, is 24 kilometers southwest from the plant site. Along a southwest path into Hong Kong Island, the map shows 4 locations labeled 5, 6, 7, and 8. The other 4 locations, labeled 3, 4, 9, and 10, are on the northern side of the Hong Kong Island. Weather conditions are specified by the user on the left side of the graphic. The wind direction can be set by dragging the needle of the compass. The wind speed, rain rate, temperature, pressure, and the atmospheric stability classes can be input by pressing the corresponding buttons. 3 different scenarios with different wind speed and direction will now be presented to illustrate the interactive nature of the dose distribution. In the first scenario, shown on the left, the wind is from the northeast at 10 kilometers per hour. This will be compared to the second scenario, shown on the right, with a northeast wind at 130 kilometers per hour. You can see how both sets of parameters are set at the beginning of the event. Next, we will skip ahead to the 6-hour mark because offsite dose will soon occur. The playback rate on the video will also be sped up to allow us to quickly cover the remainder of the first 24 hours of the scenario. As these scenarios run to completion, you can see that proximity to the plant site has a large effect on the accumulated dose. For example, Site 2 has a comparatively high accumulation in both scenarios. By comparing these two scenarios, we can also see that a wind roughly 10 times as strong reduces the accumulated dose by approximately 10 times. We have shown that wind speed affects the dose prediction. Next, we will show that the output is also affected by wind direction by comparing scenarios 2 and 3. The second scenario is presented again, but is moved to the left of the screen. As a reminder, it has a 130 km per hour wind from the northeast. The third scenario, shown on the right, also has a 130 km per hour wind, but it is from the opposite direction, the southwest. Now that we have seen the parameters set at the beginning of the scenario, we will skip ahead to the 21-hour mark and speed up the playback rate. As you can see in scenario 3, with wind blowing away from Hong Kong, the accumulated doses at all sites other than the plant itself remain 0. This is notably different than the scenario 2 results, where wind of the same speed is blowing towards Hong Kong. Design EP provides a powerful tool to study the effects of radiological release from multiple independent sources at a plant, along with the ability to interact with the environmental conditions to perform what-if analysis.